Hello friends, welcome back to my channel. So in today's video we are going to start cycloaddition reaction, and in cycloaddition reaction I will first take Diels Alder reaction, which is the most important of all. Right. So first we know that Diels Alder reaction is basically 4+2 type of cycloaddition reaction, in which we have two things here. One is diene and another one is dienophile. Right. Now this diene and this dienophile can be of various type. We can have different type of their structures. So we will take that part a little bit later, or in second part of this cycloaddition reaction. First we will understand that what are the important rules which will decide that what will be our final product, or what will be the product's stereochemistry and regioselectivity. Right. So I will take that part first, because I think that is more important than discussing that what will be your diene and dienophile. So this 4+2 cycloaddition will form new sigma bonds and pi bonds, and this will lead to the formation of ring like this. Right. We all know about the basic reaction. The important thing is this diene is generally electron rich in nature, and this dienophile is electron poor, or you can say that electron deficient, because of the attachment of electron withdrawing group. It is electron deficient in nature most of the time. It is not true always. You cannot decide that if our dienophile is attached with a electron donating group, it will not participate in cycloaddition reaction. It can participate, but the reaction condition will be more harsher. Right. So they can participate. We will take them later, that how they can participate. But one more the important thing is, generally they are dienes are electron rich and dienophile are electron deficient in nature. Means they should be complementary to each other. If our dienophile is attached with electron donating groups, if I will attach an electron donating group here, it will become electron rich. Then in that case the diene should be attached with electron withdrawing group to make the reaction faster. Right. Then we will move to regioselectivity. What is the meaning of it and how you can apply these rules? Suppose I have, in the starting I have taken that my diene is this one and dienophile is this. This is the most simplest way. Right. If suppose I have attached a group here, alkyl group is attached here, or at the second position, it can be attached at first or second position, right? Or it is also possible that we have two alkyl groups or any other groups, any other functional group can be attached here. So suppose I have a substituent at first position in diene, and in suppose dienophile I have also a substituent. Right. Now there are two possibilities that this dienophile and diene will form an adduct in such a way that we will get 1,2 product. In this particular case we will get 1,2 product. Second possibility is it will rotate by suppose 180 degree, and you will get this type of arrangement, 1,3 product. Right. These two possibilities are there. Then how you can decide that what will be your major product? So first we will take the same scenario, that first I have a substituent at first position, and this is my dienophile and it is attached with CO2R dash. Right. So again I will say that there will be two possibilities. I can have 1,2 product, or I can have 1,3 product. So in case of one substituent means substitution at first place of diene, most of the time we will get 1,2 as major product. This is our major product when we have one substituent at diene. Right. But this proportion of 1,3 product can be increased. How it can increase? Suppose I have different R and R dash here. So most of the time your 1,2 product is major product in all cases. The ratio of this 1,3 product can increase when I have CO2 Na group as R and I have placed R dash as Na, sodium, right? What is the meaning of it? Means in your product you can have this type of possibilities. This carboxyl group has negative charge and sodium is positively charged. Now two anions, two negative charge are close to each other. Close to each other means there will be repulsion. When we have same charges together, they will cause repulsion. That is why this ratio of 1:3 product increases, because it will lead to the more stability. So you have to be careful that what are the attachments. The main thing is that you will get 1,2 as a major product when you have one substituted diene, but if you have groups like this which can cause repulsion with each other, then 1,3 product will also increase, right? This is the first possibility. Second possibility is that your diene is substituted at second position. So in case of second substituent, you can have again two possibilities, that you when you will attach these two alkenes, you will again get 6-membered ring, right? But the attachments can be at 1,3 position. And another possibility is when you will rotate this dienophile, you will get CO2Me, this ester group, at 4th position, means you will get 1,4 product, this one, right? So when you have second substituent in substituent at second position in diene, then your 1,4 product will be major. This will be your major product, right? Most of the time it is true for all type, that you will get 1,4 as major product. Then next possibility is you have 2,3 substituents. So in case of 2,3 substituent, when you will form final product, the bonds will move like this, right? Again 6-membered ring will form. Now question comes that which group will decide that where this COMe, this group will go, right? Me, this methoxide group will decide, or this PHS group decide, which will decide? So this phenyl thiosubstituent will decide. It is the more stronger directing effect than the methoxy group, right? So it will decide that this COMe group will go at 1,4 position of it. Means when you suppose this methoxy group is deciding, then in that case you will get 1,3 product, right? 1,3 product. Or if you want to get 1,4 product, you have to rotate this bond, and when you will rotate this group, this COMe group will go in 4th position, right? This ketonic group will go in 4th position, right? Then you will get this type, this attachment of this group is here at this place. And because this phenyl thiosubstituent is deciding, that is why it can give you 1,3 product when you are rotating it, or it can give you 1,4 product. And we know that for second substituent, the major product is 1,4 product. Next is, it is not a category, it is an example, right? So in this case, my diene is substituted at first position, so I can have 1,2 product or 1,3 product. I have two possibilities. But in this dienophile, I have two substituent here, NO2 and ketonic. So in this case, this NO2 group is more influential than this alpha beta unsaturated ketone. So I will get this type of product, means 1,2 product in this case. This is 1,2 product, right? Then next is, so I have again this diene which is substituted at first and third position, right? And this is my dienophile. So again there are two possibilities, that suppose I am writing down this dienophile like this. So if it is forming a adduct, then it can give me 1,2 product like this, or if I will rotate this dienophile, then I can have 1,3 product, right? There are two possibilities, and we know that 1,2 is major product. So on the basis of this methoxy group, I can write down that this will be my final product. Suppose this group is also deciding in nature, so it can give me 1,3 product if I am rotating this dienophile, then it can give me 1,3 product and 1,4 product which is similar to this one. So in this case both the groups are giving us this as a major product. On the basis of this methoxy group it is 1,2 product which is major in nature, and on the basis of this trimethyl siloxide group this is 1,4 is major product. Then suppose I am further doing its hydrolysis, acidic hydrolysis. So this trimethyl group is acting as a protective group for this alcohol, so it will be removed, and this methoxy group will take a proton and it will form MeOH. Then this bond will break due to presence of this acidic hydrolysis. This will shift here and MeOH will be removed. So I will get this one as final product, right? Then we will take next principle, that is cis principle. What this cis principle says, it says that whether you are taking your dienophile or diene, right, in both the cases the attachment of your substituent will remain same in the final product also. Means, for example, in this case I have Z alkene here, this is my Z dienophile. So after the formation of product, its the attachment of these groups, these subfunctional groups will remain same. Means if they are on the same side, both of them are on the same side, in final product they will again remain in same side. So how this reaction will take place, this bond will shift here, so it will form a product like this, and these two groups will go on the same side. It can give us two type of product, this is endo product, or it can give us exo product. So we will decide how we can find out which product will be major a little bit later. One thing only you can understand here, that I can have these two type of products in which both the functional groups on the same side as in the starting. Similarly in this case this is a trans alkene, so the attachment of these two ester groups will remain opposite of each other in the product also. One group is suppose going exo, other one will go endo, right? I will get only single product in this case, because if I am writing down this one as exo, it will go endo, so then the things will remain same. Next example is this one. So now you are thinking that it is very simple example, why we are taking it, because in this case this is the scenario for dienophile. In one case our dienophile is Z, and in another one dienophile is Z. But if our diene is also have some type of geometry, some stereochemistry, then how we will decide that what will be the attachment of groups in final product also. So this thing is simple for cyclic compounds, but when question comes about acyclic, then confusion can arise, right? So first we will understand this one, then we will come to this. So in this case we have proton attached here also. So when you will form product, right, this type of product will form. So this CH2, this methylene group is inside, suppose this is inside, right, inside the ring, and these two hydrogens which are on the outer side will also remain on the outer side of the product, going away from these two carbons, right? So this thing is important, that whatever the attachment in the starting, it will also be maintained in product also. Now you can come to the acyclic examples. So in this case we have two phenyl groups which are on the suppose on the outer side, right? So in product also they will remain on the same side. You can think that they are trans in nature, so they should go in opposite plane, but this is decided on the basis of symmetry of the molecule, right? The starting materials are also symmetric in nature, so the product should also remain symmetric. That is why they will remain on the same side. So this is very important, that in the starting your diene is attached with the two groups which are on the same side, which are Z, which are trans in nature, right, which are moving out of the molecule. So same thing will be maintained in the product, means their attachment will be on the same side. We will take another example, then this thing will be more clear. In this case, one alkyl group is moving inside of the molecule, means it is a Z alkene, and in this case it is a type of E alkene, right, and this alkyl group is moving out. So these two alkyl groups have opposite type of arrangement. So in product they will also attach in opposite direction. One is suppose going above the plane, other one will go below the plane. So you will get this type of product. In this case, again the same thing, this group is forming E alkene and this one is forming Z alkene. So these two are attached on the opposite side. So in the molecule, in final product, they will again remain opposite to each other. If one is going above the plane, another one will go below the plane, right? So this is about cis principle. I think these two things are very clear to you, regioselectivity and cis principle. We are moving one by one, step by step, so we can solve questions, right? Next rule or the last rule is endo-addition rule. Endo-addition rule is first given for cyclic compounds, then we will move to acyclic compounds, right? So endo rule says that when we are forming this cycloaddition product, this type of product will form in which we have this bridged carbon, right? And question comes that you can have here two type of products, this one, another one is this one, right? So now you can decide this is our exo product and this is endo product. We know that this is cavity site, and when the groups going towards the cavity they will form endo product, and when they are moving away from the cavity they are forming exo product. So on the basis of stability, exo product should be more stable, or we can say that they are thermodynamically more stable product, thermodynamic product, and these endo product are kinetic product. So it is considered that most of the cycloaddition reaction or most of the pericyclic reactions all are concerted reactions. Concerted reactions means they are going in single step. So when reactions are going in single step means they are much faster in nature. So they should give product on the basis of kinetics, right? So that is why this kinetic product is measured in case of this cycloaddition reaction. So we will get endo product as measure. So whenever the conditions which are favorable to kinetic product formation, we will have kinetic product as measure product, and when conditions are favorable for thermodynamic product, then thermodynamic product will be measure. Means when you are carrying out the same reaction, same cycloaddition reactions under high temperature condition, very high temperature condition, then you will get this thermodynamic product. And when you are carrying out these reaction at low temperature and moderate temperature, then you will get kinetic product. We will come to this point again. So this is a general explanation. Then suppose instead of your this cyclopentadiene, I am taking here furan. This is an exceptional case and it is given in most of the books, so it is important, it can confuse you, right? So we think that the endo product should be the major product, but in this case our exo product is major in nature. This one is major because it is considered at room temperature. At moderate temperature, kinetic products are not stable. The kinetic products formed after the reaction of this furan and this maleic anhydride, they are not stable in nature. That is why it is forming thermodynamically stable product, that is exo product. So remember the exceptional case. This is the exceptional case for furans. Then we will take another example. This is for acyclic compounds. This is the case for cyclic dienophiles and dienes. Now I am taking acyclic one. So this is slightly difficult. So how we can decide that which will be the final product? It is given in very good manner in Clayden book. So I will take that part from Clayden. So first to determine the final product, first we have to write down the possibilities. What are the possibilities here? we can have two type of product. So first thing you should know that these two methyl groups are going out of this molecule, right? So we have discussed in cis rule that when the groups are going on the same side, they will be remain same in the product also. So same thing will be applied here. These two methyl group will go on the same side, whether we are taking below the plane or above the plane, they will remain on the same side. Suppose they are going above the plane, then possibilities for this aldehyde group is that it can go above the plane, sorry, below the plane, or it can go above the plane, right? We have two possibilities here. If you want to denote them in dash way, then you can do that part also, right? They are going in on the same side and this is going on the opposite side, right? We can have two possibilities here. So how we will decide that which will be our major product? That first we will write down this diene as such, right? Then this dienophile will go below this diene. This is the frontier molecular orbital concept, that we should place this diene above side and dienophiles attack from the below side. So we will write down in the same way. I will denote it by different color so it will be more easier. So we will write down this dienophile in such a way that it will form a final product, and this CHO group will go under this diene. We have to rotate it in such a way that it should go under this diene. So first important thing is that we have to write down diene as such and dienophile in such a way that this double bond will form a product, should be aligned in such a way that it will form a product, and this carbonyl group will go on the below should be covered by this diene. So this is the first step. In second step, what we will do, we will again write down it in same way, but this time we will write down proton attached here also. So one proton is attached with this carbon, one is attached with this one, right? We have two protons here also, but there is no roll off there, so we will not write them. We will write at this position, right? So second step is we have to locate protons. Then next step is that we will form final product. Final product is formed like this 6-membered ring, right? And we will write down CHO here as such. We will not write down its stereochemistry first. So next thing is that because all these protons are moving in the same direction on the right hand side, they all are on the right hand side, so they are cis to each other, they all are cis in nature, means in final product they will always also remain cis in nature. This proton will go suppose above the plane, so attached on this carbon, this one, it will also go above the plane. We will not write down the stereochemistry of methyl in this step again, and this proton will also go cis, means above the plane, and methyl will remain suppose as such. In final step, now we know the stereochemistry, the attachment side of these protons, so we can write down the stereochemistry of products also. We can write down the attachment side of these groups also. So methyl will go below the plane because above the plane side is occupied by proton. Same thing will happen here, same thing on this carbon. So this is our endo product and this is the major product. So follow this rule and you can find out which will be your endo product or major product for acyclic diene and dienophiles, because in this case you cannot decide that which will be your endo side or which will be your exo side easily, right? So this thing is, I think, useful. Follow these steps and you can achieve it. We will do many problems related on this concept. First we will understand that what is the effect of temperature. So in the starting I have told you that whenever we are deciding that exo product will form or endo product will form, means thermodynamic product will form or kinetic product will form, then temperature can help us. At high temperature thermodynamic products will form, I should not write it down here, otherwise it will be confusion. This at high temperature exo product is favorable, because not all time temperature conditions are mentioned. They will simply give you heating, so you cannot decide in that case. So if you have given very high temperature, then you can consider the formation of exo product. Otherwise at low temperature or moderate temperature, endo product will be major product. The next is, we will take certain examples based on the rules which we have discussed so far. So in this case, what we will get as final product, first we will write down the product, then we will decide the attachment side of the groups. So we will get this type of product, right? The question comes, what will be the attachment side of this acid group and proton? So when we are deciding the product type in acyclic, then we have seen that all these protons are cis in nature. When we are aligning these diene and dienophile in this way, then these all protons will become cis to each other. They are the protons present on this carbon at this position and at this position, they all become cis to each other. Means in this case also, if we have a proton attached here and at this position, these all will become cis to each other. Means this acid group will go below the plane, right? So this is our endo product, so it will be major in nature. So this is the question. This type of example has also come in net examination. So in this case they are using tetrabutyl ammonium fluoride. So this will basically provide us fluoride which will attack on this silicon. This bond will shift here, this will shift here, and this will be removed. So in this case there is formation of this diene, right? So next, if we are using a dienophile, then we can do a cycloaddition reaction. So suppose we are using this one as diene. Now we will apply our endo rule and cis rule. So first we will form product, then we will decide what is the stereochemistry, what will be stereochemistry. So after cycloaddition, this type of 6-membered ring will form. First we will write down these groups as such, then we will decide what will be the attachment side of there, right? This will be the product. Then these two methyls are moving out of the plane, right? Means their attachment side is same. So in the product also their attachment side will remain same. This is according to our cis rule. Then what will be the attachment side of these groups? This can also be decided on the basis of cis rule, that these two are attached anti to each other. So in product also they will remain anti in nature, right? So you can place this group, if you are attaching this one is below the plane, this one is above the plane, answer will remain same. So there is no difficulty here. But if you have different type of groups attached, then you can apply endo rule. We will take more example. So suppose in this case we have here this is our diene and this is dienophile. So in this case, first there is formation of 6-membered ring like this, right? And I will again write down all the groups as such, then we will decide their attachment site, right? We will get this type of product. Now we know that these two groups are trans to each other, right? So they should remain trans in product also. So suppose one is going above the plane, another one will go below the plane. Now what will be the attachment side of this group, this amide group? How we can decide it? We will have to apply endo rule here. So according to endo rule, suppose first I am writing my diene as such, and then I will write down this dienophile. So how I will write that? Suppose it is forming a product like this, and this CHO will go below this diene. Then what we will do, we will attach protons. In next step we have to attach protons. So we will attach all the protons. Now all these protons are moving on the same side. These two are moving on the same side, this one is going on the opposite side. So in final product, so first we will write down the next step, then we will determine the final product. So first we will write all these functional groups as such. These two protons will go on the same side, means they are cis to each other, and this one is like this, right? So If these protons are going above the plane, these two group will go below the plane and this methyl will go above the plane. So these two groups are anti to each other, that is in the starting reactant, and these two groups are cis to each other, right? So this is our endo product, means this will be major. In this case we have taken this one as above the plane, so you can do the same thing here. If you are placing these two protons on the same side, means these two are cis to each other, so I have written them above the plane. I can also write them below the plane. If I am writing them below the plane, then these two group will go above the plane, similar to this case. Ultimate result is these two should remain on the same side and these two on the anti side. So this is the final product. So I think you can easily apply all these rules. Remember, first you have to check the regioselectivity rule, then you have to check your cis rule, then third rule is endo rule. Apply all three rules together and then you can find out your final product. This is my 100% guarantee that you can do your answer correct if you are applying all these three rules in correct way. Then in next case we are taking here, this one is again 4+2 cycloaddition. So simply these two groups which are going out of this molecule will remain on the same side. Here we have this ester group also, it was missing in the question. So if these two groups are going out of the plane on the same side, so in product also they will move on the same side, right? Now you can apply the endo rule, that proton on this carbon and on this carbon will go on the same side and these two groups will go on the same side. According to the endo product, we should have product like this, means this CO2 Me group will also go above the plane, right? This one. If you can apply endo rule by your own, applying all these things. If you have any confusion, you can again ask me in the comment section, but I think it should be clear to you. So we will get this type of product form. Then we are using MCPBA here, so this phenyl sulfide will form sulfoxide. We can also write down this sulfoxide in this form. It will show 2,3 sigma tropic shift. So I will explain you how it can show 2,3 sigma tropic shift in next videos, right? So there is no rule to explaining it here. We will take it later. Then we will move to next example. In this case again we have to apply cis rule and endo rule, right? So according to cis rule, these two groups will go on the same side. And about regioselectivity, we have two groups here, this acetate group and this trimethylsilyl group, and out of these this acetate group is more influential, right? That is why we are getting here 1,2 adduct, this one, right? So next question comes about the endo rule. So we know that according to endo rule, the proton attached on this carbon and this one will go on the same side, means they will remain cis to each other. It means this acetate group and this ester group will also remain on the same side. This will be our major product. This is also called as endo product. Now we can use this is major, means we will also get some minor product in which this CO2 Me group will go below the plane on the opposite side of this acetate group, right? We can further use this compound in the reaction as given in Carruthers, that they are using osmium tetraoxide. So when we are using osmium tetraoxide and we have acetate attached here which is above the plane, so I have explained you that this OH will go on below the plane side on opposite side and their attachment side will be same, means there is syn dihydroxylation. Then further they have used TSOH, means acidic condition, so it will show Peterson elimination. These two groups will be removed which are anti to each other, so we will get double bond here. So same thing will be applied in next net examination, that they can give you mixture of all type of reactions. They can give you name reactions, reagents and pericyclic reaction in same question, right? So you have to apply all things together. Then next thing is that in this case we are getting this one, we can have two possibilities here, that we will get this one as product and this one, right? There are two possibilities. So in this case our dienophile is acyclic and this is diene cyclic in nature. So we cannot decide that endo product will be major or exo will be major. It is decided on the basis of alkyl R group attached here. If it is proton, then your endo product, this one, this is endo product and this is exo product. So this endo product will be your major product. Suppose you are getting 75% here. When you are using methyl and ethyl, this one will become 35% and 0%, and in phenyl it is 60% and 30%. So you have to memorize these things a little bit, because it cannot be decided easily by looking at them. We cannot decide by using any rule here, right? So you should have idea about them also. So I will finish this part here. I have not covered all the Diels Alder reaction here, because it is, I think it will become more difficult to you to understand all the things in single video. I will cover next part and upload the second part soon, right? So thank you so much for watching, and if you like my videos, please share my videos, and all the best for examination. Please do revision of all the videos we have covered so far, Clayden book summary and in Carruthers. Please do revision of all of them, and thank you so much for watching.